Alright, so for today's video, I wanted to go ahead and finish our topic on compound inequalities. Today in class, we looked at the OR compound inequality, but we didn't get a chance to talk about the other type of compound inequality, which is called the AND inequality. So for today, we're going to go ahead and make sure we go over this page. But before we do that, I just wanted to quickly go ahead and cover questions 5 and 6 under the OR compound inequality. So let's go ahead and review 5 and 6, and we'll go ahead and go from there. So let's go over to number 5. And in class, please remember that the idea is to solve for each of these inequalities individually. Once we do that, then we can go ahead and move further. So here in this first inequality, you're going to want to distribute this 3. So let's go ahead and do that. You should get 15 minus 6k is less than negative 12. And here, there are different routes you can take at this point. But what I always recommend to everyone is that we keep the variables on the left-hand side. That is completely optional and entirely up to you. So I'm going to go ahead and do that. I'm going to keep this variable on the left-hand side. So therefore, in order for that to happen, we have to get rid of this 15. So we would subtract 15 from both sides. And you should be left with negative 6k is less than negative 27. Now we divide by negative 6 on both sides. So therefore, your k is greater than, please don't forget this important point. Whenever we multiply or divide by a negative number, we have to switch the inequality sign. So once again, we have to switch the inequality sign because we're dividing by a negative. So here we switch the inequality sign, and you should get a negative over negative, which is a positive, so 27 over 6. So that would be your solution to this first inequality. Now let's go ahead and go over to this side. We do the same thing. We distribute the 1 over 3. So you should get 15 over 3k minus 9 over 3 is less than or equal to negative 3. Once we've distributed the 1 over 3, we can go ahead and simplify these fractions. So you should get 5k minus 3 less than or equal to negative 3. And then at this point, we would add 3 to both sides. So you're left with 0 on the right-hand side. And then at this point, we would divide by 5. So therefore, this is another type of symbol for therefore, sort of like an arrow. So therefore, our k is less than or equal to 0. Because 0 divided by 5 would be just 0. Okay, so now that we have solved each individual inequality, please don't forget that when you're using the compound inequality for OR, you're going to need to make sure you put them side by side. So let's go ahead and do that. I'm going to put it up here. And I'm also going to put the other one. All right, since we're dealing with the OR compound inequality, we have to put in the OR in the middle. Okay. So that would be your answer to the first part of the question. And just an FYI, 27 over 6 is actually equal to 4.5 if you plug it into the calculator. And that'll help us with this number line. So let's now look at the number line. Let's start off with this inequality. We'll have an open circle at 4.5, and then everything to the right of that will be part of our solution. Okay. Now let's look over to this one. Sorry. K less than or equal to 0. We would have a closed circle at 0. And then everything to the left would be filled in. All right, so now that we have constructed our number line, we can go ahead and construct the interval notation. So we can use this number line to help us create this. So based on the number line, we will be coming from negative infinity, reading it from left to right. We're coming from negative infinity to 0, bracket, and then since we're using the OR compound inequality, we would write the union symbol, and we would finish it off with parentheses 27/6 to infinity. So once again, this is the first part of the answer. This is the second part. And then we have the interval notation. All right. So hopefully number 5 makes sense. Let's go over to question number 6. Similar process. We have to solve each individual inequality, but we have to be real careful with this one. So I'm going to go ahead and rewrite this first one. All right, so here, for this one, in order to isolate the x, we have to get rid of this negative 3. And we do that by multiplying both sides by negative 3. Okay, so once we do that, the negative 3's will cancel out. And you're just left with 8 minus x. Since we're multiplying by a negative number, please be real careful here. Since we're multiplying by a negative number, we have to flip the symbol right here. So we go this way. And then negative 5 times negative 3 is positive 15. We're really close now. We would subtract 8. Therefore, you have negative x is greater than or equal to 7. And at this point, you can either multiply by negative 1 or divide by negative 1 to get rid of this negative. But please be real careful here. So you would, once you do that, you would have x is less than or equal to negative 7. So please be real careful here, since we're either multiplying or dividing by a negative here, we have to flip the symbol. So this would be the first inequality solution to this first one. Let's look at the other one. I'm going to rewrite it. 5 minus 3 over 2x is less than negative 1. Let's go ahead and solve for x. So you should get minus 5 minus 5. Negative 3 over 2x is less than negative 6. We're almost there. And then, going back to our algebra concepts, there are different ways to approach this, but how do we get rid of this fraction is the question. In order to get rid of this fraction, we multiply by the reciprocal. So let's multiply by the reciprocal, so it'd be negative 2 over 3. Okay. Please remember that the reciprocal is just this switched. So the numerator and the denominator switch places. And don't forget this negative sign when you're multiplying by the reciprocal. So then we multiply both sides by negative 2 over 3. And since we're multiplying by negative, we have to switch the symbol. Okay. Once again, we have a negative. We're multiplying by negative, so we have to switch the symbol. So you're left with x is greater than 12 over 3, which simplifies to 4. Remember, negative 6 times negative 2 is positive 12 over 3. All right, so now just one more step here. I'm just going to copy this. I'm going to put it up here, and then I'm going to put the other one side by side. And since we're dealing with the or compound inequality, we'll write or here. Okay. So that should be your answer to the first part of the question. Now let's go ahead and graph this compound inequality onto the number line. So let's focus on this one. We start off at negative 7, filled in, and everything to the left will be filled in. And then looking at the second one, x must be greater than 4. So we have an open circle, and everything else is filled in. Okay, so this is how your number line should look like. Now that we have our number line, we can go over to the interval notation. And our interval notation, from reading it from left to right, should be negative infinity to negative 7, bracket, union, parentheses, 4 to positive infinity, parentheses. Okay. So once again, we solve for this compound inequality. From here, we were able to construct our number line. And then from the number line, we were able to construct our interval notation. So hopefully that makes sense. And let's go ahead and go over now the topic we didn't cover at the end of class. Let's go over a different type of compound inequality. Once again, in the first page, we went over the or compound inequality. And please recall, with the or compound inequality, we have a disjunction present. But let's go ahead and investigate what we have under the and compound inequality. So for the and compound inequality, let's look at the number line they gave us. And notice here, this number line is a little bit different from the other one. Now, x is actually in between two x values, right? We're in between. X can lie in between this interval. So what we call this situation is a conjunction. So it's not a disjunction like we saw under the or compound inequality. This is what we call a conjunction for the and compound inequality. So let's talk about how an and compound inequality is written. So for the and compound inequality, we would write our inequality as, if we look back at this graph, notice that we start at negative 2. So therefore, for the first part, x would have to be greater than or equal to negative 2. But at the same time, it has to be less than 5. So we're going to put an and in the middle and say that x also must be less than 5. And remember, this is coming from this specific number line. And now the only difference is that we have to put the and in the middle. And please remember that we are restricting our x values within this interval. Okay, so let's talk about the interval notation for that. So just based on looking at this graph, this number line, the interval notation would just be bracket -2, and we go all the way to 5. And we put a parentheses around the 5 because that value isn't included. So that's pretty much it for the interval notation. So let's go ahead and go over to the next section. So if you read this section, this is allowing us to, or this is mentioning rewriting the and inequalities. So because the solutions to an and inequality fall between two endpoints, as you can see in the number line, they are frequently written in a more condensed form. So what I'm going to go ahead and do is rewrite what we got up here. So once again, this was the inequality we talked about earlier, and it has that and statement. So instead of writing this entire thing, there's actually a more efficient way of writing it, which is called the condensed form that they are referring to. And we write it by, we write it like this. So it would be -2 is less than or equal to x is less than 5. And that's pretty much it. So we're saying that our x values have to be restricted within this interval. Okay. So let's go ahead and jump right into the examples, and we'll see what we mean. So for number 7, if you look at number 7, we have the same idea here. Now we're talking about an and inequality. We follow the same process like we did before. We solve each inequality. So let's go ahead and do that. So for this first one, we subtract 3. You get 2x is greater than -12 divided by 2. So therefore x must be greater than -6. And then if we look at the other inequality, we add 2. So therefore 8x is less than 32. We divide by 8. So therefore x is less than 4. All right, so now we would write them side by side. And in between, we would add in the and statement. All right, and another way to write this in a more condensed form is this. So this right here, we take into account both inequalities. An alternate representation of this is just -6 less than x less than 4. All right, so once we've constructed the condensed form, we can go ahead and construct our number line. So we have -6 with an open circle, and we end at +4 with an open circle. So everything in between will be shaded. All right. So now that we have constructed our number line, we can go ahead and construct the interval notation. And that'll just look like this. So parentheses, -6, because that's where we start. We go all the way to 4. Parentheses. And that's pretty much it for question number 7. Okay. So I'll leave you to try to do question number 8. What I'm going to go ahead and do is also send over the solutions, but follow the same process that we looked at in question number 7. Okay. So once again, I'll send the solutions over to number 8, and I want you to try that out. So let's go over to number 9. I think looking at number 9 is definitely going to help you out in the homework. So let's look over number 9. So in number 9, notice in number 9 there's a huge difference. So if you compare 9 and 7, question number 9 doesn't have the and statement anywhere in there. So if we look at question number 9, we don't have the and statement, but we know that this is an and inequality. So what we can go ahead and do is work with all 3 of these sides at the same time. So here's the idea. The goal is to be able to isolate A. And in order to do that here, if we focus on this middle one, we have to get rid of this negative 1. So in order to get rid of that negative 1, we're going to add 1 to all the sides. So you add a 1 here, you would add a 1 here, and then you would add a 1 here. So therefore, we have negative 2 plus 1, which is negative 1 is less than or equal to. These cancel out, so you're just left with A is less than or equal to 6 plus 1, which is 7. All right, and that's pretty much it. Now we can go ahead and construct our number line. So let's go ahead and do that. So if we look at our number line, we start off at negative 1, close circle, and we end up at 7 with a closed circle. Okay. And everything in between is going to be filled in. Okay. And then right away we can construct the interval notation, and that'll just be, it'll be bracket negative 1 to 7 bracket. And that's pretty much all we do in question number 9. So just to recap this question, in the beginning, what they gave you is really just a condensed form, make sure to write this down, a condensed form of the and compound inequality. So this condensed form that they are referring to, we're definitely going to go ahead and cover that again in our next class when we talk about absolute value inequalities. So we're definitely going to be seeing this condensed form again. All right, let's go over to number 10. Same idea for number 10. Our goal is to look at this middle section and isolate the variable they give us. Here it's P. So let's go ahead and isolate P. We do that by subtracting 4. So we subtract 4 to all sides. So therefore, 4 minus 4 is 0 is less than 3P. This cancels out, is less than 15. We're still not done with the middle term. So we can divide by 3 to get rid of the 3. And then you do it to all sides. So we have 0 divided by 3, 15 divided by 3. 0 divided by 3 is just 0. Is less than, now we just have our variable P, is less than 5. And there you go. You have isolated the p variable, and you have constructed this interval. So from this interval, we can construct the number line. Let's go ahead and do that. So we start off at 0 with an open circle, and we stop at 5 with an open circle. Everything in between is going to be filled in. All right. So from this number line, we can easily construct the interval notation. Would just be parentheses 0, 2, 5, parentheses. And that's pretty much it for question number 10. So let's go ahead and go over 2 more examples. And that should help you complete the backside of the homework assignment that I had given you last class. So hopefully questions number 9 and 10 make sense. So let's go ahead and go over to question 11. So same ideas here for question 11, but please remember that you always follow the rules of the inequalities, just making sure that if you ever come across a point where you multiply by a negative or divide by a negative, you switch the symbol. So those rules still apply when we're dealing with these types of inequalities. So let's jump right in to this and inequality. It's written in the condensed form. So we have to isolate the variable they give us, which is m. In order to do that, we would add 2 to both sides. To all sides, sorry. So all sides right here. So 28 plus 2 is 30. And 30 greater than negative 10m greater than or equal to negative 5. All right. And then here at this point, be super careful. We're going to divide by negative 10. So since we're dividing by a negative number, we have to switch the symbols. So divide by negative 10. We do it to all sides. So therefore, 30 divided by negative 10 is negative 3. We switch the symbols. Don't forget that because we're dividing by a negative. And we're left with m. Switch the symbol. This was simplified to 1/2. Positive 1/2. So now that we have constructed our interval and isolated our m, we do the same thing. We construct the number line. So we start off at negative 3. Open circle. And we end up at 1/2, which is somewhere around here. Okay. And everything in between here will be filled in. Okay. So then now we can easily construct our interval notation, which should just be parentheses negative 3 to 1/2 bracket. So these are actually my favorite types of compound inequalities. I think they're just a little bit more easier to work with and compared to the or compound inequalities. So let's look at number 12, and hopefully question 11 made sense. So let's go ahead and jump over to question number 12, which is our last question for this video. For question number 12, we have to be really, really careful. So I'm going to go ahead and just rewrite the and inequality they give us. I'm going to put just a little bit of space after that, negative 2. So once again, we look at this middle term. Our variable here is x, so we want to isolate that. In order to isolate the x, we're going to have to get rid of everything else. So here we got to get rid of that negative 2. So we're going to have to multiply this by negative 2. And whenever you do to this term, you have to do all the other sides. So multiply this side by negative 2 and then this other side by -2. And please remember that they're being multiplied. So here, if we look at this, -2 times -5 is +10. Be real careful here. We're multiplying by a negative, so we have to switch the symbols. So it would be greater than or equal to 12 minus x. It's greater than -2 times -2 is +4. Then we follow the same process. We subtract 12 from all sides. So therefore we have -2 is greater than or equal to -x is greater than -8. Okay. So here we're almost there. We just have to get rid of this negative. So once again, you can multiply the whole thing by a -1 or divide by a -1. I'll just choose to divide everything by -1 to get rid of this negative sign. So we'll also do the same for all the other sides. So I'm going to rewrite everything over here from our space. So because we're dividing by negative, please don't forget we have to switch the symbols again. So we have -2 divided by -1, which is +2. Switch the symbol. Now you're left with x. Switch the symbol. And then now you're left with +8. All right. Now that we have constructed our interval and isolated the x, we could go ahead and construct our number line. So we start off at 2, close circle, and we end off at 8, open circle. Everything in between will be part of our solution. All right. So after we construct the number line, once again, we construct our interval notation, would just be bracket 2, 2, 8, parentheses. All right. So hopefully question number 12 makes sense. Once again, please be real careful when you're multiplying or dividing by a negative. You have to make sure that you switch the symbols and be consistent with that throughout the whole process. And that's what we did here. So now, hopefully that helped out. And now you should be able to complete the homework assignment that I gave you last class, specifically the backside. So please make sure that before next class on Friday, you're able to complete the whole backside of the Solving Compound Inequalities homework worksheet. So once again, this will be due on Friday, September 15th. And if you have any questions, please feel free to reach out to me at any point. I'm always happy to help. Once again, today we finished covering the OR compound inequality and the AND compound inequality. And next class, we'll be talking about, next class, we'll be talking about solving absolute value inequalities. In order to solve absolute value inequalities, we have to have an understanding of the OR compound inequalities and the AND compound inequalities. So we'll go ahead and come back to this when we deal with solving absolute value inequalities. All right, so hopefully this video was very helpful. Once again, if you have any questions, please feel free to reach out to me. And I hope you have a great rest of your day. Bye-bye.